Welcome back. Today we're going to continue section 4, so dividing polynomials. However, now we're going to learn something called synthetic division. Now, honestly, this is a very new way, so sometimes it looks intimidating at the beginning. However, I actually love this method of dividing, and I think you'll probably see that it's a little bit more user-friendly than long division is. So there is one restriction on this, okay? The reason that we can't only teach you synthetic division, even though it's more user-friendly, is because it only works on binomials where the variable has no coefficient. So what that means, you can only use it when you're dividing by things like x plus 3 or x minus 4. If you're dividing by something like a 2x minus 1, not going to work. The x cannot have a coefficient with it, and it has to be linear. So you couldn't even divide it by something like that. Okay? So let's take a look at how this works. Now, the little overview thing, I'm just going to skip over because that is actually more for your benefit. So if when you're going back doing your practice work, if you kind of lose track of what's happening or why it's happening, you can go back and look at that. But I'm not going to spend time discussing it because I think starting from scratch is going to be more to your benefit. All right, so for synthetic division, the first thing you have to identify is what is your magic number? Okay, now what I mean by that, your magic number comes from this, all right? However, the magic number is not -5, okay? The magic number is the opposite of what you're seeing. So the magic number is actually just the number 5. And I always offset that, okay? So that's how you always start. Identify, and I jokingly always call it the magic number. And then all you have to do, I'm going to put a 1 there, is line up the coefficients of what you're seeing. So I have a 1x cubed, negative 8x squared, a 17x, and a negative 10. Then leave a little bit of space, and I'm going to draw my line down there. My work goes above the line. What ends up below the line is actually my answer. So to start this process, I'm going to pull down that first number. Okay? Whenever you get a number down there, okay, you multiply by the magic number. So 1 times 5 is going to give me 5. And that goes into your next space. Whenever you have numbers lined up like that, now you add. Negative 8 plus 5 is a negative 3. Whenever you have a number down there, just like I said a few seconds ago, now I multiply by the magic number. Negative 3 times 5 gives me a negative 15. Whenever I have numbers stacked, I add. 17 plus negative 15 is going to leave me 2. Now I have a number down there, so 2 times 5 gives me 10. I have two numbers stacked up. I add to give me a 0. I always offset that last number because that last value that I got is my remainder, all right? The last thing you end with is always your remainder. So here it's kind of neat because this means my remainder is actually 0. Now we have to go back and we have to reconstruct the polynomial, okay? The 1, negative 3, and 2, just like what we started with, those are coefficients of a new polynomial. So I'm going to reconstruct this. So this is going to be my constant term, my x term, x squared term, and then you could keep going with x cubed, x to the 4, but here this is all that we need. So my answer is x squared plus, x squared minus 3x, then a constant of 2. So that is the answer when I divide these two things. All right, so again, I don't think this is difficult by any means. It's just kind of recognizing this new process. All right, so let's do it again. So first thing, I'm going to identify that magic number. So this time, my magic number is going to be 1, right? The magic number is always the opposite of what you see. And now I'm going to line up my coefficients, and I'm going to put 1s there so you know where my 1s are coming from. 1x to the 4, 2x cubes. Oh, I'm sorry. 2x cubes. Now here, just like when you did long division, here notice that your x squared term is missing. If there is a term missing, you need to represent it with a 0. So I have 0x cubes, 1x squared, and then a negative 3. And then of course now you want your line down here. So let's run through our process. So pull down the 1. Whenever I get a number down there, I want to multiply by my magic number. 1 times 1 gives me 1. When I have two numbers stacked, now I want to add. So that's going to give me 3. I'm going to take that, multiply it by the magic number. 3 times 1 is 3. Now add. Multiply, add, multiply, add. All right, and then I always offset that last number because that last number is always the remainder. So I keep that separate from everything else. And now to write the actual solution, okay, when I divide the two polynomials, what I'm getting is a polynomial, but I have to reconstruct it. That's going to be my constant, my x squared, x cubed terms. So what I'm left with are the coefficients of a new polynomial. So I have x cubed, 3x squareds, 3x's, a constant of 4, and then a remainder of 1. And what that remainder means, remember, the remainder is still being influenced by whatever you were originally dividing by. All right, so use synthetic division to check if x plus 2 is a factor of x cubed plus 2x squared minus 4x plus 5. What does it mean? Well, if we are looking to check if something is a factor of another polynomial, we're using synthetic division, but we're looking for having a remainder of 0. Remember we touched on that back in long division? Having a remainder of 0 meant you had a factor of that original polynomial. So let's use synthetic division to check if this in fact is a factor. So when I look at what I'm dividing by, okay, I'm looking at that, my magic number is going to be negative 2. And then I line up all the coefficients. 1, 2, negative 4, and 5. And we're going to run this through the synthetic division process to see if this is in fact a factor. I'm going to pull down the first number and then of course multiply. Add, then multiply. 0 times negative 2 is still 0. Add, multiply, add. All right, so do I have a remainder of 0? Well, no, I don't. Okay, so is x plus 2 a factor of that? No, it is actually not a factor. Okay, so again, you can use synthetic division to check if something is a factor or not of another polynomial. Now, let's backtrack a little bit. So on this one, we did get a remainder of 0, right? Remainder 0. So again, what that means that that polynomial x cubed minus 8x squared plus 17x minus 10, what it means is that x minus 5 really is a factor of it. And what's the other factor? Well, the other factor is the solution that we got. So again, just to reemphasize this idea, because it's going to come back soon, the idea that when you get a remainder of 0, synthetic division and long division are actually kind of a factoring process for you. Okay, it factored out that x minus 5 to show you you have left x squared minus 3x plus 2. All right, so that's all that I have for you today. Because again, I don't think it's difficult. I think what's more important is just now that you've seen it, now you're going to need time to practice through these skills. So do make sure you write this summary for me though, a little bit of what you picked up on today, and then just come back ready to do your practice work.